On this worksheet, you're going to be determine whether relation is symmetric about the x-axis, the y-axis, or the origin, or there may not be any symmetry with respect to x-axis, y-axis, or the origin. So in that case, you would say none. It is possible for a relation to have more than one symmetry, and so you just list all the ones that are appropriate. So if you look at number one, if you notice, and sometimes it helps to have a ruler available, but if you notice, let's talk about uh, the origin symmetry, which is what this is. So see, here's the origin here. So if I take this point here, right here, and if I take a ruler and then at the origin, and I look at this distance here, this distance from here to here, whatever that distance is, and go straight down across here, that's the same distance. So the question is this point right here reflected by the origin going to be that point? So you can't really tell what the coordinates are here. But let's say this is, I'm making this up. Let's say this is 1, 2, 3. Let's say this is 2.5 comma 5. Okay, I made that up because I'm not sure what, you can't really tell what these coordinates are. And then over here, let's say this is negative 2.5, negative 5. So remember, in previous lessons that for origin symmetry, if the point xy is on the graph, then its opposite is also on the graph. So notice negative 2.5 and the opposite of 5 is negative 5. So those are on the graph. And you just continue the process. So notice if I go, let's say here, right here, and I take that point and go about the origin like this, I'll get this point here, which indicates that the coordinates are opposite. So this is, again, I'm making this up because I really can't tell what the coordinates are here, but let's say this is 1.2 negative 3, then this right here would be negative 1.2 positive 3. So they would be opposites. Okay, so it's pretty easy to determine if a relation, if a graph has origin symmetry. Just kind of use this idea here. Take a point of the graph, go across the origin, and see if you get a point here, and see if those are opposites. Notice that this is not origin symmetry at all, right? In fact, it's not even, so this is origin right here, I'm sorry. Here, that's not origin symmetry. In fact, if you take this point here, I'm not going to draw it because it's going to mess it up. Take this point here, go across the origin. The point, that same distance, lies here, and that's not on the graph. So notice it's not y-axis symmetry because this is y-axis symmetry, right? So notice that for y-axis symmetry, if you take this point here, take that point here, and then remember y-axis, here's the y-axis, this distance and this distance should be the same. And so you get this point here. This distance and this distance should be the same, and you get that point here. And the thing about those points is this, and I'm making this up. So if this is, let's say, I'm making this up now, if this is, let's say, 2, 3, then this would be negative 2, 3. So for y-axis symmetry, the y values stay the same, but the x coordinates are opposites. All right, so just notice the distances though. So this distance is the same as that distance. That distance is the same as that distance, the distance to the y-axis. All right, so this is y-axis symmetry. For x-axis, that's this one here. So if I do the same thing, this distance to the x-axis and this distance to the x-axis, those 2 points here, the relationship is this. So if this is, let's say, I'm making this up, 4, let's say 3, then this point here would be for negative 3. So for x-axis symmetry, the x coordinates stay the same, but the y value are opposites. And so notice if I go this distance and then go this distance more, the same distance, I should get that point in those coordinates. The x values would be the same, but the y coordinates would be opposites. Okay, so this would be x-axis symmetry. So notice though, if I go back to this one, here this is not symmetric about the origin. It is definitely not symmetric about the y-axis because look, this distance is not the same as that distance, right? So it cannot be symmetric about the y-axis. And it's not symmetric about the x-axis either. So you would say none here. Same thing here. There's no symmetry here. You would say none. But here, though, I want you to notice something. So notice this. It is symmetric about the origin, right? You see this? Symmetric about the origin. If I take that point, go through the origin, and that same distance, I get that point. Same thing here. Go same thing. This distance equals that distance, and I get that point of the graph. So we know it's origin symmetry, right? We know that it's x-axis symmetry as well. Look, x-axis symmetry. If I go this distance, I'll get this point. If I go this distance, I'll get that point. See that? So if I take this top portion here, this right here, and reflect it about the x-axis, I'll get the bottom portion. All right? So it's x-axis symmetry. It's y-axis symmetry as well because if I take this part of the graph that's on the other side of the y-axis and I reflect it, I'll get this part. All right, so it's y-axis symmetry as well. So it's all, in this case, the circle that has the center at the origin. The circle that has the center of the origin has all three symmetries. Okay? All right. So just remember though, not all circles will have all three symmetries. It's only the one, listen carefully, it's only the one in which the circle, whatever the radius is, has its center at the origin. All right. So that is the key to topic 17. Part A.